I know we talk a lot about power supplies, but there's a good reason for it. They're really important to any control system. I have a couple of examples here, but if you look at any of the examples on the bench behind me, the common factor between all of them is that every one of those must have a power supply. Its job is to convert the AC electricity, that's the supply into the building, into an output that's DC for all of our control components. There's a couple of important things that we have to remember about DC power supplies, and the first one is, fortunately, they're all pretty much a standard voltage. 24 volts is a really common industrial standard for power supplies. But for residential components, the things that you use in your house, often 9 volts or 12 volts is really common, so you can't always just go find a spare power supply laying around and use that in place. Another thing is the screw terminals. If you've ever used a power supply that has one of those those round connectors that plug in, they're really easy to unplug, especially if there's vibration. So these screw terminals with the proper torque, those make sure that all of your devices are connected very securely. That 24 volts is only part of the equation, and sometimes we can get away with saying the bigger the power supply, the more power it outputs, but sometimes that's a little bit misleading. I've seen some large power supplies that really don't have much power output. Although if it's very small, it's usually only designed to supply power to a few devices. Let's take a look at these ones and see how much power they provide. 24 volts is the common factor between them. And again, the common factor in those power supplies in all the benches behind me, 24 volts. This one at the top says DC 24V 4A. Now the 4A is for 4 amps. How much power is that? According to Watt's law, we multiply voltage times current, which means 24 times 4, which is 96. 96 watts, that's almost 100 watts. When you load a power supply, which means once all the devices that are connected to it, we got solenoids, relays, contactors, all these 24 volt devices, when all of them are running, the voltage might actually drop a little bit. That's pretty common. Most of these power supplies will have a screw terminal somewhere on them that when all of your load devices are running, or when the most that are running at any point are running, we can adjust that small potentiometer to get an exact 24 volts at kind of a worst case scenario. Turning to this smaller one, it says 24 VDC 0.42 amps. So just barely a half an amp. Now, if we do that calculation, voltage times current, that gets us to 10 watts. I verified it on my calculator. Voltage times current is the power. Once we've added up the total power consumption of all the devices in our facility, we need to make sure that we have enough power to be able to run them. But what happens if you don't have enough power? If you've chosen too small of a power supply? Well, the good news is that's another thing about industrial power supplies that they thought of. Instead of the components inside burning up, which can happen when you load a power supply too much, instead it'll simply turn off the outputs. So designers will very often stick an extra set of terminals in here that's a switch, turning on and off when the power supply is running. So you immediately know when you've overloaded the power supply and it's time to either redesign your system, look for some sort of a flaw like a short circuit, or add an additional power supply that's appropriate for your system.